So this is 1.8, and we are continuing for a third part for our lesson. This is exactly where we left off. If you, for whatever reason, missed out or wanted to re-look at something, you can pause the video before I move on. To the square root function. So as we define, again, ignore this page number. As we define the square root function, we want to point out for the domain that we only want to square root 0 or larger numbers. Now, the reason why I hesitate to say positive numbers is because 0 is technically not positive. So you might hear me use the phrase non-negative. Because when you say non-negative, you are also including 0 in that phrase. I'm sorry if that bothers you. That is the correct math term. So as we look at this problem, we just look at what's being square rooted, and we say we can only square root positive, or there I go, saying the wrong thing, non-negative numbers. So ignore the square root, just look at the argument, that's what I said in the previous video, or radicand, and greater than or equal to 0. So now, very straightforward, just subtract 3 over, so x must be greater than or equal to negative 3. This actually might help some of you realize back in an earlier where we talked about shifting left 3, that this sort of explains that. You know, if I were to look at the graph of this, now I'm kind of not answering the question. It shifted left 3, and then if you look at that graph, you can clearly identify that that goes from negative 3 to infinity. Anyway, this is what I was looking for by just doing math without looking at a graph. All right, let's see if we can do that on the next one. Now, the next one, if you followed our old rules, you probably are noticing that y-axis reflection. I hope you noticed that before we do it. If not, I just told you. But our math, the way we do math, still works. If we take the argument or the radicand and set it greater than or equal to 0, well, normally we would subtract 4 over first. And then when you divide by a negative, think for a second, what happens when you divide by a negative? That inequality switches. So this actually explains why that y-axis reflection flips everything around. So instead of going left, in this case, instead of left 2, it's going to be right 2. And the reason why it's right is because you could factor out a 2 out of that. But anyway, now think about how you would write it in interval notation. If we want all values smaller than 2, then we're going infinitely to the left, and then we stop once we get to x equals 2. This is how we want to write the answer in interval notation. All right. Moving forward, really the same kind of work. Greater than or equal to 0, subtract 1. When you add or subtract, there's no switching inequalities. When you divide by a positive, there's no switching the inequality. So there's no reflection on this one. So how would we write our answer? Negative 1/3 to infinity. Now, just to, I'm not trying to confuse you, but let me just put in a new thing into this problem. I'm not changing where the radicand ends, where the radical ends, I guess I should say. But let's say I put in a +7 on here. Would that change your domain on this problem? Well, the quick answer is no, because all you do is you take the radicand, the argument, and set it greater than or equal to 0. Now think about what adding 7 does to the graph. Shifts it up 7. Well, that's changing the range. Up and down changes the range. Does up and down change the domain? No, it does not. So I'm going to leave that. I'm not going to erase it because the answer is still the same. And I kind of wish they gave an example that did this. You know, if I revise the notes, I could obviously come up with a new one. But I think that's good enough. All right. And then the last one, if I was in a huge rush, I would just say cube root positive, cube root negatives. It does not matter. So based off of your conclusion from before, because we can cube root positives and cube root negatives, I guess I should also mention cube rooting 0, because that's technically not included in positive or negative. But all three of these situations are okay. The domain is always all reals. So this is true. There's no arithmetic to do, at least for this one, because it doesn't matter what's the argument here. Doesn't matter what the argument here. But now let's stick a wrench in everything, because as we look at this third example for h of x, yes, it's a cube root, but is there an issue within this? Yes, there is. What can we not do? Cannot divide by 0. So just because you see a cube root, don't automatically jump. Look a little closer, and in this situation, we'd have to identify that the denominator cannot equal 0. So subtract 1 over. I feel like just doing this. Divide by 2. And how would we write this in interval notation? We would just say, okay, from negative infinity to negative 1/2, and then union negative 1/2 to infinity.